Hey guys, it's Vince. Today in this video, we're going to be taking a brief look at a potential client's mocked up CNC system that he's once again asking me questions on. I get this question now at least 15 to 18 times a week. That is, how do I recommend a potential client, or anyone for that matter, stage their system as far as where they're going to mount their VFD, where they're going to mount the drives, how many power supplies, so on and so forth, porting, fans, cooling. Let's do a quick breakdown. And before we do a breakdown, I want to clear the air, so to speak, so everyone understands what they're dealing with when they're researching information online. You as the end user, if you're going down the DIY path, you must hold yourself accountable. From the very beginning, you are accountable. That means that if you go and purchase overseas components, like we see many of these here, you are the end-all be-all person that's going to support the system. I just did a video a couple days ago on a past client that imported the system from China, and he's getting virtually no support with. Okay, you, on the other hand, will probably be down that same path if you purchase overseas components. Do not get reference manuals, do not get wiring diagrams, have no understanding of precision electronics dealing with robotics, no understanding of stepper motors, no understanding of VFDs, no understanding of EMI, no understanding of double shielded cables. It can go on and on. And the reason I'm trying to not necessarily scare you but awaken you is the fact that there is a lot of misinformation online, and many of you have experienced it, whether it be from a forum who you don't know who you're learning from, or even YouTube, who, once again, we really don't know who we're learning from. We see an excerpt in time of somebody running a system and it looks like, oh, hey, he machined this. But we don't know if he edited the video. We don't know how long he's run the video. We don't know how long that machine has been run stable. So you pick dribs and drabs of it to implement in your system, and you hope you're doing it right. Well, let's look at fact and let's look at fiction. Okay, looking at this, and this is probably one of the biggest mistakes I've seen done. China started doing it, and now it's been bled over here, and I'm seeing it done more and more and more, and it's terrifying. We see a VFD being installed literally inches from the drives. Okay, why a VFD would be installed in electronics enclosure with the CNC drives that are going to be, once again, sending and receiving signals to your motors, I have no idea where this is coming from, other than people are thinking they're making their system neat. Let me tell you what you're actually doing. The VFD, and let's just break it down to what it is. It's essentially a power supply for your spindle motor. Okay. Now, the thing you have to understand is that you are looking at what we are going to generate when this unit fires. And of course, a spindle motor is simply going to draw amps up and down based on the resistance it's put under. It's basically just a regular AC motor. Okay. The EMI goes up and down, and this unit emits large amounts of it. The most it will emit of the entire system, because again, it's drawing the most power. Most of these are three-phase output. So once again, once you install this unit inside the proper electronics enclosure, which this end user looks like he's using, it's a steel cabinet here, you are basically going to have a Faraday cage which is encasing all of the electromagnetic interference when this unit is on, when that door is shut, and it's basically trapping it around your drives. Okay, and for those not familiar with a Faraday cage, look it up, Google it, take some notes on this video, and trust me, this is not best practice at all. China started doing it. I don't know why they started doing it. I think they started doing it because it would make end users feel that, oh, look at how neat and tidy my system is. The thing you have to factor in, guys, unless you're controlling your VFD through the software, this digital interface right here with that potentiometer on it is how you will control the unit speed. Once this cabinet door is closed, you have no accessibility to this knob at all if, once again, you are not controlling your robot's spindle through the software. So essentially, you're going in and out of the cabinet all the time in order to actually adjust your VFD. Now, best practice would be dismounting this VFD from the electronics enclosure and mounting it on a wall separate from your CNC between 5 to 10 feet away. Now, why is that best practice? Because we can mitigate EMI two ways. Okay, naturally we use our shielded cables, double shielded cables, we use proper grounding, but the biggest way, the most cost-effective way to mitigate EMI is distance. So again, if you just distant your electronics that are sensitive from EMI type components, you're going to naturally mitigate EMI at a much higher rate, and then you would add your cabling in. And I have guys that will say, well, I can't do that. I can't have 10 feet. Okay, well, be reasonable. How about 5 feet and buy your double shielded cables and everything else is set? Now, your digital interface, then I get told, well, my digital interface then is too far for me to make adjustments to. You're correct. It is. How do we rectify that? Well, it's running on a cable as well. I have a cable in my store that is an extension cable. It is designed for that. Why is it 40 feet? It allows you to have basically a VFD interface module so that you can walk around with your actual digital interface and adjust your speed at will, or mount it to the front of your controller. This is the idea behind that. When you start seeing these problems, that's where the engineering side comes in, is that someone most likely has already encountered them, and it's just a matter of understanding how do we rectify it. But we never, ever, ever want to mount our VFD in best practice inside a steel enclosure, literally inches from our drives. Okay. The other thing I want to point out aside from that, we see it's a 4-axis system, or at least it's got 4 drives installed. Okay. Whatever components you go to purchase, you must make sure as a DIY guy, you are getting the proper documentation with all of your system components. If your vendor doesn't provide you that, and the manufacturer of the components don't provide you that, and you don't check that prior to making your purchase, you are to hold yourself accountable. You are going to take a chance on saving a big amount of money in terms of your idea of, hey, I can buy these components, I see what's being done online, I'll figure it out, then figure it out. But if you're going to pay a third party, or you want to get a third party involved, you can rest assured they're going to expect payment, because it's not cheap in time to rectify your problems. So again, be realistic. What we see here with these drives being mounted at the top of the chassis along with the VFD, let's say it was okay to mount the VFD in this. And let's say it was okay to have the drives that close to the VFD. Why would you mount anything at the top of the chassis? And the reason I say that, heat rises. So it doesn't make sense to mount anything at the top of the electronics enclosure when heat rises. Have you ever noticed that most power supplies for computer cases are at the top of the chassis? Have you noticed that? Most of them. Some gaming units may be at the bottom depending upon how their fan system is, and that was where I was getting next. It does not matter so much on component placement if the fans that are going to be integrated in the system to once again give her proper cooling is placed properly. But optimally, direct placement of drives should always be at the bottom of the system. And if you reference my systems, that's where they are. Drives are always separate from power supplies, which he did here. Okay, but they should never be on the top of the chassis in this particular instance. There's absolutely no reason for that. This should have been down here. Once again, VFD removed, drives on the bottom. Now, as far as power supplies, let's analyze this. We've got 4 individual power supplies. I'm assuming one's going to go naturally to each drive. Okay? What that tells me is whoever purchased this or whoever put this kit together, they're just trying to make money. And the reason I'm saying that is anyone involved in CNC robotics understands you do not need 4 individual power supplies for drives individually. Is it best practice to have individual power supplies? Can it be done? Yes, it can be done. Is it best practice? No, it's not, and I'm going to explain why. What you're doing is amplifying the amount of EMI. And once again, we know our VFD generates the largest amount of EMI. However, when we have 4 individual power supplies, exponentially we're increasing our EMI the more we put these switching power supplies in here. And once again, once that door closes, you're going to trap not only the VFD's EMI, all the EMI then generated by these 4 power supplies on top of the additional one we have here, which even though it's a baby, again, if it's electronic, it's generating EMI, and we're putting it right around our drives. So you've got this massive amount of EMI trapped inside this steel Faraday cage. Just same way that when this door is closed and properly grounded, it is essentially going to be dissipating EMI from the outside world. If it's encasing it inside of it with the steel because it's conductive, you shut that door, all of that EMI once again is radiating around these drives. So we have to pay close attention to what we're doing. I mean, essentially very close attention. So the other thing I want to discuss is when you're using individual components like this, the other factor is, yes, and I get this question a lot, if you were running one drive to one power supply, if one power supply fails, you still have 3 drives. That's correct. Okay? But we have to look at this case of mitigation of EMI because stability is always going to overtake that in that prerequisite. Because when we look at engineering and we say, let's look at this from a perspective of failure, what is more apparent in terms of failure? Stability at this point, when we look at how critical it is that we're generating that large amount of EMI around our drives, or do we look at the potential of a power supply failing? And I can tell you right now, if the power supply is selected correctly with the proper amount of amps to support the system, you only need a single unit. I will say it again. You will only require a single power supply with the proper amount of amps to drive your CNC system. Now, how many amps that is actually going to be required is based on how the motors are going to be hooked up and based on, again, the drives being used. Every drive, every motor is different. So you need those specs to go in and determine exactly what's to be done. Now, I want to point out something now that's very interesting. We see these standard switching power supplies, and I just came out 48-volt unit, which now has 10 output terminals. And you can see the 10 output terminals here in both V positive and V negative. What these power output terminals do is supply your unit power. And you can see we've got the 3 standard actual inputs for live neutral ground to power the unit. And then we have the output terminals to once again supply your accessories all the power required. You can see it here when it's fully assembled. You can see the labeling on the front. V positive is the back terminal. V negative is the front terminal. Why did I do this? Okay. In the system, he's only got 3 output terminals on these power supplies to actually supply power to his drives. If he has more accessories that he needs to power, he's got to install terminal splitters, increasing labor, increasing cost to actually do that. So he's got to split his power from however many of these he has, and this is just hypothetically depending upon the system being produced, because he doesn't have the proper amount of output terminals for power supported by these power supplies. Why? Because it's not designed for this application. So once again, overseas vendors are putting these kits together. I can tell you right now because I've seen this many times. They're putting it together in the cheapest possible format so that it looks like you're getting high dollar, high value type componentry because they're putting a whole kit together. But what you're not factoring is the engineering that goes around it because, again, stability overtakes everything. And in this particular instance, a single power supply, like you see here, allows you to expand the system without adding additional work. On top of this power supply also having a built-in EMI filter. Okay, something once again to consider is you're looking at that and seeing what difference is that going to make. So he could have definitely saved labor by eliminating all 3 of the units, or I should say all 4, and going with a larger power supply that has enough amps to supply all of these drives. It would increase his stability, and if he added an EMI filter either in the power supply or externally, that would help even further. Again, removing the VFD from the chassis, that's absolute must. And again, direct placement of the power supply should be at the top of the enclosure away from the drives, where the drives will be at the bottom of the enclosure or closest proximity to where they will be exiting in terms of motor cable entry through the bulkhead. Once again, if you review my Raptor system, you'll see how close they are in proximity to where the drives are going to naturally be outside the system in terms of the bulkhead, where they're going to be exiting out to once again have the plugs of the GX16s come in and go run right to your motors themselves. So again, looking at this, we already see there's things here that need to change. The other thing I want to point out, and I see this being done a lot, and I know it's because commercial systems use it. When I see these cable guides here used, the thing you have to remember is this. When you put these in, they look really nice. The problem is when you go to service the system, you got to snap these on and off every single time. And the only reason I'm making you aware of that is for some guys it's a headache, other guys love them. It's totally up to you. I personally am not a fan of them because when I want to service something, I want to be in and out quick. All you're doing is making yourself create more time in the event you have to change a drive or have any part that needs to be changed. You got to remove all of these cable guides and then finally get over to your actual wiring to actually manipulate it. And it's the same thing again. You're putting it all back. Now, some guys, once again, they don't mind it. We're going to be supporting your business with a robot. I highly recommend you think about what I'm talking about. Because if you think the robot will never fail or a part will never fail, you're going to be sorely mistaken. And again, time is money. So keep that in mind. Simple is always better. Now, later on, if you decide you want to do that or expand the system, you're more than welcome to do that. But I'm telling you right now, you really want to be careful with how many doodads we install to make the system as clean as possible. Absolutely, wire management is critical, but using wire ties works just as well, and you can still service the system in a matter of minutes, so to speak, in terms of how easy it is to get a part in and out and, once again, a new component installed. So keep that in mind. The other thing we need to think about is fan placement. In a system like this, you definitely want to have what's known as a cyclonic effect. And a cyclonic effect simply means we want air to come in and go out. Okay? And typically how we do it is we bring air in from the bottom where it's coolest, and it's going to be extracted from the top where it goes over the power supplies and leaves. If you look at my Raptor system, that's exactly what we have. We did that for a reason, because if cool air is coming in and hot air is going out, there is no way for stagnant heat to stay in the chassis any longer than it has to. You always get what's known as that cyclonic effect, and you're basically formulating a turbine effect of air, similar to like a tornado. It comes in, it goes out, and it gets in that rotary fashion. And that's exactly what we want to do. So again, a high CFM fan, whether it's 60 mil, I prefer the 60 mil fans because again they're smaller, the high RPM. You can use a 120 mil fan. It's completely arbitrary to the end user. It's also based on how big your chassis is that you're using. So again, keep in mind the voltages, keep in mind the CFM. I wouldn't use a fan that's any less than 80 CFM. That means you're most likely going to be using either a high RPM fan that's smaller or, again, a larger fan. Maybe a 120 millimeter usually will definitely easily handle that. So just keep that in mind. And again, matching your voltages. Just also remember that you're going to need more power to supply those fans power. So having a single power supply here is the best way to go. You're still going to have an additional power supply, most likely for the fans, if they're not running all 48 volts. So again, you can see how my engineering all ties in. All of my fans with my G540 systems all run on 48 volts. Why did I do that? I didn't have to use a separate power supply. Okay? So again, you start looking at the engineering and it's like, I see what he did. Now it makes sense. That's what we're trying to do here. Everything should not only be functional but logical so that you're able to service it at any given time, and once again with proper documentation you're set to go. So again guys, I hope that this video has been answering some of your questions. These are the majority of questions I get answered. I see power distribution units being used, breakers being used, everything being used. Just keep in mind, you can install anything you want. Don't waste your money on superficial things. Fuses for the system should be installed. Most high-end drives do have fuses internally in each one, which are replaceable. I always recommend an external fuse on the outside. You see my systems are not elaborate with internal breakers. I'm not doing all that. I mean, you really don't need that, and especially if you're using quality components. Once again, you're going to have redundancy anyways due to the fact that, like I stated earlier, the drive itself will have an internal fuse. VFDs typically have an internal fuse, and with a VFD externally mounted, if anything did occur, it's much easier to troubleshoot. That's the other thing, guys. Keep in mind, the more you put in this cabinet, if you have a problem, that's another item that you have to isolate from all the rest. So let's say you have something malfunction. Well, out of this cabinet that we have just in here right now, this guy's got to troubleshoot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things, and this could be a potential for an 11th. So the more we separate, the easier it is to troubleshoot. So that's why, like on my ESS turnkey solution, you don't see me installing in a chassis like every other vendor. Why? Because if I keep the controller separate and you have a problem, you can disconnect it instantly and see what the problem is. Simple is better. It saves time, it saves money, and it keeps your system running faster due to the fact that we are able to isolate those problems and eliminate them very quickly. That is, to me, overall the best way to go. And as you develop your system, you'll figure it out. Over time, it will come to you. It's just a matter of figuring out these base points. Now, as far as him milling in his ports, once again, port location will all be achieved once he knows direct placement of his components. But I think we've seen here what not to do. Power supply should once again be at the top of the case. Drive should be at the bottom of the case where it's the coolest. VFD removed. Single power supply used here. 5-volt power supply, if that's what's going to be used for his breakout board. That's another option in terms of that. Due to the fact that I have seen guys use wall power packs and other things, but it's really interesting to think that if you're not using a dual rail power supply like the one I have designed with the 48 volt for fans, and it has a 5-volt power supply built into it on the second rail, so it supplies 2 different voltages. By doing that, you're only using one power supply to power 2 different units with 2 different voltages. By using a power supply like this, he still has to add this power supply in addition to all his drive power supplies. So he can minimize, he's got 4 here, 5. If he uses one single power supply to power all his drives, now he only has 2. Then he's also going to have 1 for his fans. Now he has 3, but it still beats the hell out of having 4, 5, plus 1 for his fans is 6 on top of the VFD, and you see exactly what I'm saying. It keeps extrapolating. The different power structure you need, you're going to need to look, how do I branch it up to where I can get as much power out of each unit that I need without creating more and more and more electromagnetic interference. So again, I know that this video went a little longer than expected, but hopefully I covered a lot of your questions. And again, I know that videos always add more questions. In this particular instance, though, you can see here what we're dealing with this system. I hope that the end user actually does get the system set up. We can see this does have what looks like to be a removable tab for his components, which is great. But again, I think we've covered a lot here to hopefully get him on his feet. I wish you guys all the best. And again, if you have questions, require quotes, you can message me direct at storm2313@gmail.com. You can also message me through my eDealer Direct store. eDealers is once again on eBay. You'll see the links in the beginning of the video and at the end. I thank you all for your support. Take care.